Hello class, this is the second example of restricting the domain of a function to make the inverse a function as well. So let's get straight to it. So you can pause the video and try and figure out where this function is always increasing. A little piece of advice I can give you is find some stationary points. In this case, that is a stationary point. So for increasing, it would definitely stop at 3, not including 3. But for its lowest value, notice how if we try and draw a tangent at this point, at 0, it's actually abruptly stopping there. So if we were to actually draw a tangent, it would be completely vertical like so. Okay, so that means the domain for always increasing, it starts at 0, not including 0, up until 3. Which, if you want it in inequality notation, would be as follows. Well, now that you've seen this, it's not too difficult to find the domain where this function is always decreasing. Since its highest value is 6 for the x, and its lowest value, since we're only going from the decreasing portion, that means it's beginning at 3 and ending at 6. Which in inequality notation is as follows. Alright, so now that we have that, let's move on to sketching the inverse of these functions. Let's do increasing here on the left and decreasing on the right. And first, let's highlight the section that we want for the always increasing portion. Well, for this, the always increasing portion is going to be from 0, not including 0, up until 3. So the portion we are looking for is this one here. Now that we have that, let's draw the inverse of this function. Well, let's switching this around. 3, 3. Switching those points will also be 3, 3. So let's highlight that in blue. Open circle. And switching 0, 0 around, well, that's also 0, 0, which gives us a bit of a problem, because how do we sketch this function? Well, recall that the inverse is perfectly symmetrical, well, it's perfectly reflected along y is equal to x. So since the orange function kind of goes outwards like this, the inverse, since it's going this way, the inverse would go the other way like so. It's kind of making a circle going this way. That there is the inverse of the always increasing portion of that semicircle. Let's try it again for this. Once again, switching these around, it would become 3, 3 once again. So we have that point. And switching these around to find the inverse point would be 0, 6, which would be there. Oh, I forgot to highlight the portion that we need. There we go. And similar to the previous one, it's sometimes hard to imagine how to draw the inverse. And a way to get around that is just imagine that line, y is equal to x. And since this function goes outwards to the right, well, looking at it this way, it's kind of going outwards here, meaning this would go outwards in the other direction like so. So the inverse would be something like, let's try to draw it this way, like that. One more try. Whoops. There we go. It's the best I can do it. And there we have it. Oops, get rid of the purple line. Well, now that we have that, let's find the domain and range of the inverse of these functions. The domain for the blue function, it starts at 0, not including 0, and it ends at 3, not including 3. As for its range, its lowest value is 0, and its highest value is 3, not including 3. And for this one, we can see that its domain starts from, it starts from 0 because its lowest x value is 0, but not including 0. And its highest x value is 3, not including 3. As for its range, its lowest value is 3, not including 3. And its highest value is 6, but not including 6. And just to emphasize the point of the domain and range switching from the function to the inverse, the domain of the orange line starts from 3, ends on 6. So take a look. The domain of the orange function starts on 3, ends on 6. And its range starts on 0 and ends on 3. So the lowest value of the orange function is 0, and its highest is 3. Note how the domain of the orange function has become the range of its inverse. And the range of the orange portion is the domain of the inverse. So that concludes the second example. Hope to see you in the third. Best of luck.